Okay, so now that we've seen how we determine empirical formulas, let's take a look at a problem. A 3.24 gram sample of titanium reacts with oxygen to form 5.40 grams of the metal oxide. What is the formula of the oxide? Well, titanium is a metal, and when it reacts with a nonmetal, it forms an ionic compound. And this ionic compound has oxide as its anion. So when they say metal oxide, they're talking about the compound that results from titanium reacting with oxygen. So pause the slide, and using the rules that we went over in the last voice lecture, see how far you can get. We'll go over it when you restart the lecture. So let's review the rules. If we are given percentages, we change the percentage symbol to grams. However, in this case, we already have grams, so we don't need to do that. What we're going to do is convert the grams to moles, and we do that by dividing our given mass by the molar mass of each element, which we find on the periodic table. So we're given 3.24 grams of titanium and the fact that the total compound weighs 5.40 grams. Our goal is to find an empirical formula in this format where we determine the subscripts x and y through our calculations. So first, we need to determine what our conversion factors are for getting our mass to moles. Here's titanium on the periodic table, a metal on the metal side, and here's oxygen, a nonmetal. So we know, just to reinforce, that this is going to be an ionic compound. From the periodic table, we see that 1 mole of titanium is 47.88 grams, and 1 mole of oxygen is 16.00 grams. So to be able to calculate our molar mass, be able to calculate the amount of moles, we have to know the mass of each element. We're given the grams of titanium, but we are not given the grams of oxygen. We've got to calculate that by subtracting our mass of titanium from our total mass of the compound. The compound is made up only of titanium and oxygen, so when I subtract away the mass of the titanium, I'm left with the mass of the oxygen. Once I have the two masses, then I can calculate how many moles. And we do that by, here's our railroad math set up. I have grams of titanium here, grams of titanium goes down here, mole goes on top. Grams of oxygen go on the bottom. It's very important that you label everything very carefully when you're doing your math, so you're sure to cancel out the correct units. So let's look at correct sig figs. Here are our answers in correct sig figs. I have 3 sig figs here, 0.0677 moles here, 3 sig figs, 3 sig figs here, 3 sig figs here. Once we convert our grams to moles, then we write what we call a pseudo formula using the moles that we just calculated as our subscripts. Once we do that, we divide each of our subscripts by the smallest number of moles. So here is our pseudo formula, Ti0.667, 0, and then oxygen 0.135. And then we take the smallest value, which is 0.0677, and divide it into the other moles. And when we do this, we get Ti1 and O2. Since these are whole numbers, we have no more work to do, and a check is that 1 and 2 have no common factors except for 1. So this is a good empirical formula. Let's take a look at this practice, which takes us a step further. Determine the empirical formula of stannous fluoride. So this is not the standard IUPAC nomenclature, which contains 75.7% tin and the rest fluorine. So pause the slide and see how far you can get. So let's look at our rules. If we have percentages, we've got to convert them to grams, and this is where we are in this problem. And then once we have our percentage to grams, we're going to convert our grams to moles by dividing our masses by the molar mass of each element. Here is tin on the periodic table, a metal, and here is fluoride, a nonmetal. So these two are going to form an ionic compound. Okay, so let's look at what we have. 75.7% tin, so we're just going to change that to grams. And to figure out what percentage of fluorine we have, the rest is fluorine, so we subtract this from 100 to get 24.3. And again, we just change our percentage to grams. The molar mass of tin on the periodic table is 118.70 grams. The molar mass of fluorine is 19.00 grams. So we do our railroad math and we get the moles of each. Once we have the moles, we do the pseudo formula, and then we take the smallest number of moles and divide it into each. When we do that, we get the empirical formula SN1, F2, and there's no common factor between these two values besides 1, so this looks like it's a good empirical formula.